All right, so a quick bit of background. For the first 20 years of my industry life, I was busy in dealing with internationalization for Apple and Palm and a bunch of other companies. And then about 5 years ago, I started a company, a VC-backed company called Krugel. It has nothing to do with Google. It's based on my last name, and it was a search engine for open source code. So in order to make that work, what I wound up doing was building a company around these brand new technologies, Nutch, and then Solr, and eventually Hadoop. And one of the first things we wound up doing was doing large-scale web crawls, and we were doing web mining, where we were extracting information about open source projects, and we were parsing billions of lines of source code to make them searchable. So that was my introduction to solving big data problems using Hadoop. Since then, back in 2009, I started a consulting company called Pixel Labs. So we build custom data mining, big data analytics solutions using Hadoop. We are heavy users of Amazon's EC2 and Elastic MapReduce technologies for cloud. And I also teach classes on Hadoop and cascading and Solr. As a result of this activity, over the past year, I started seeing a pretty common trend around issues understanding the results of big data analytics. And a couple months ago, I gave a talk at a government conference back in Washington, D.C. That was sort of around the same topic, so I figured I would cover the same materials here tonight. So the key assumptions when I was talking at this government conference, I'm like, you either have a big data problem or you will soon. Ultimately, what you're trying to do is take a lot of data, basically take petabytes of data and turn it into pie charts is the common process that hopefully somebody can take and do something with. And a key point is, you get these results, you crunch this, amount of data that no one human could understand, you've turned it into something, but you have to both understand that result and believe it. You have to be able to validate it. And so the one point I'm hoping everybody here leaves with is that if you don't have the ability to poke at the raw data somehow, it becomes very difficult to actually do those things of validating and understanding the results of big data analytics. So, back in the good old days of small data. So, there'd be a meeting and somebody would stand up and say, I've done some analysis and here's the problem. Our sales in Oslo suck because we're not doing X, and they have some graphs and charts up there. And inevitably somebody in the room says, no, I don't believe that. I talked to Joe and I know that's not true. And at that point then, you pull up the spreadsheets. And you'd start looking at the spreadsheets at the data. You'd actually be saying, okay, show me the numbers that we shipped on this date. And that will help me decide whether your analysis is valid or not. And there'd be a lot of arguing back and forth, but eventually, in general, at functional companies, and not at dysfunctional companies, but at functional companies, you'd be able to come to an agreement. So, what happens now with big data? Here's an example. So we had a project where we crawled about 500 million pages, and our clients wanted us to essentially reverse engineer PageRank. So calculate PageRank and then validate it against some PageRank numbers that they had for several million websites. So to actually calculate PageRank on that scale, it's sort of like solving Satan's spreadsheet. It's like this 500 million by 500 million spreadsheet. And you're doing this analysis. And then, at the end of the analysis, we get some results, and the client's like, well, CNN.com, its PageRank you got is 7, and it should be 9. So, then we're like, okay, well, how do we prove that we actually did it right, or right means at least by the definition of the data that we have and the processing we're going to do on it? And what we wind up doing is running other jobs, right? Running endless jobs. Okay, now we're going to focus on just a subset of this whole graph of all the links between web pages, and it just went on and on and on. Another example, this is one that I actually did for that government conference. you know, is kind of sponsored by Basis Technology. Basis Technology has this natural language processing toolkit called Rosette that lets you do things like name entity extraction, data extraction, etc. So I said, great. What I'll do is I'll take all this web page data that I've got, and I'll extract people's names off of it. Like on this page, I've got John Boehner, and Kudlow, and Obama. Those are named entities that I found, and I'll get dates, September 8, 2010. And what I'll do is I'll find all these and I'll omit every single combination off of a page that has in Hadoop sort of key value pairs. You know, so a bunch of dates and a bunch of names. And then what I'll do for any given date is I'll find the most common name, and that's the name associated with that date. It's kind of like building a people timeline graph automatically. So I wrote the job, cascading, it didn't take me very long. I ran it, and I got these results for certain dates. You know, May 1st. Brian Gold was the #1 person. Okay, was there a problem with my analysis? Was there a problem with my data? Does that make any sense at all? You know, how do I validate that? So that's where I quickly turned my presentation on using, you know, Basis natural language processing into like finding useful stuff into why I needed search, why you need search, or some kind of ability to poke at the raw data to validate and understand the results. So now we're at the point of how does search help? And to understand here, when I'm talking about search, I'm not talking about search like, you know, ranking search results. What I'm talking about here is essentially using a technology called Solr to do very efficient searching of large data sets where the searches are typically queries. Find me all the entries with this name on it and this date range. And I'll explain why I was using Solr for that. But the key points are what I did and what you can do is as part of your data processing workflow, you can generate a search index. And it's not that hard. It's not that hard to add that as part of what you're already doing. This resulting index then gives you an efficient way to poke at the data. And even if you're not able to have all the data in there, even if you have to sample it down to get it into the size that you can deal with in a reasonable size search index, it still gives you something where you can actually poke at the data. That's the key point. And as I mentioned, these are typically not searches. Like I don't really care about the ordering, they're queries. I want to say, often what I'm interested in is how many, right? How many pages had John Boehner on it for this date? So they're really queries, not searches. So I built an index, I did the search up at the top there, find Brian Gold on that particular date, May 1st, and I got back these results. And what I realized is that on May 1st, this guy, Brian Gold, published a whole bunch of charts about the dairy feed cost, and that just happened to be the most common thing in the data set I had. So it validated the result in that, yes, the result was correct. I got enough hits to explain why that was the #1. And it also showed me that I kind of had a data problem. This data set that I was using here was a slice of the data that had a lot of EDU in government domains in it. So I wasn't getting like popular culture stuff. What I was getting is like the most important academia for a given date. So it was not surprising that it was skewed. So another example, I teach a Hadoop plus Solr class for Lucid. And I wanted an example of like doing complex analytics in Hadoop to generate your Solr index. So I said, great, here's what I'm going to do. I'm going to take all these web pages I've got, and I'm going to process them like normal, so I've got a searchable index on title and content. But the cool thing I want to do is I'm going to automatically generate labels for pages. So what I'm going to do is for every page, I'm going to generate all the 1 to 3 word phrases, and then I'm going to pick the best phrases for a page, where best means phrases that aren't too common and not too rare, because I'm using these phrases for faceted search. And it's kind of this Goldilocks problem where if I do a search and I'm going to have facets over on the side that'll let me narrow the search, I want to have phrases that are likely to occur. So if I had a phrase like Ken's super blog, okay, that would be great for narrowing, but the odds of that actually showing up as a facet on any search result, like being in this set of search results, is very low. But if I pick the word like the, yeah, great, every single search result, the would be a facet, but it doesn't do any narrowing. So there's this challenge of how do you pick sort of the right, sort of not too common, not too uncommon set of terms. So I did analysis on this data set. And I got these really interesting results where a couple things, like this is a subset of it with 2,000 pages. The word the is not on every page. And I would expect the to be on every single page. And the other issue is like research is occurring more frequently than the word can. And that doesn't make any sense either. So again, I plugged in an ability to generate a searchable index as part of the workflow. And I did the search, and I found that, again, I was using the same slice of my data set, which was heavily skewed towards EDU and gov domains. And so the word research is going to show up a lot more than you would expect, especially in page titles and things like that. And the other issue is I searched for pages that didn't have the word the on it, and there's a whole bunch of pages that are only JavaScript. As they don't really have any content, and the titles often don't have the word the in it. And that explained why I didn't get 2,000 results. I got something slightly less than 2,000 results for the word the. So again, this is an example of how I could quickly, because I had a search index, understand and validate the results of this workflow that I built to do data analytics. So, I mentioned Solr. One of the interesting things about Solr, yes, I could put these results into a normal database. But what's cool about Solr is like in Amazon terminology, like a C1 extra large instance. I built an index that has 1 billion things in it, has 1 billion URLs from our crawl database, and I can search it on that one machine. So it scales extremely well for this particular use case. So that means I don't have to worry about setting up a cluster of servers and handling like federated search across them. I can do it with a single server often. Or I can downsample a little bit so that it fits on one server. It's easy to integrate the workflows because I've got a cascading tap, this thing that's for writing to Solr indexes. So for me, I just can plug this into my workflow and I get the index without, like 5 minutes of work. And another key thing is it supports query style usage. So Solr lets you define fields in your schema where you can do things like range queries, which is often very critical for this kind of use of search to understand the data. So how do you do it? I figure I'd dive a little bit into the nuts and bolts for the programmers around here. So there's 3 typical approaches, and I'm distilling down like a half-day class into like 4 slides here. So pardon the brevity. There's 3 common approaches to building a Solr index and a workflow. One is the simple, cheesy way, like you output text files that are suitable for importing into Solr. So you output text files with columns that match up to your Solr schema, and that's really easy. From your Hadoop workflow, like your map or reduce tasks, you can make HTTP requests over to your Solr master using Solr-J, the Solr-J client, and that's pretty easy too. Or the solution that actually scales well is where you use something called embedded Solr, where essentially on every single reducer in Hadoop, you like fire up this little mini Solr server, and I can write the index directly onto the hard disk there. And the reason why that's great is that scales well. Right? If I have a 50 server cluster, I'm essentially writing, or 50 reducers in my cluster, I'm essentially writing in parallel 50 shards to an index. So why use Hadoop? This is a key question. Why use Hadoop with Solr? If you're building an index, if the index is your end goal as opposed to the index being sort of an afterthought to help you understand the results of your main workflow. So one of the key things is the scalability. So we're building everything in parallel. So I just processed 180 days worth of data for a customer, where each day has like 6 million records, and I generated an index from it, and on a 50 slave cluster, it took me a couple hours to do. Where if I was like trying to somehow do that directly with Solr, it would still be running, and that was like a week ago. Another key point is the ability to analyze multiple records of data sources. So, for example, think about the nudge case. Now, one of the interesting things about nudge is that it got you realize the key advance that Google had made when it came out was that they were using the anchor text from links as really highly weighted search terms on the page the link pointed to. Right? It's like human curated terms. That was one of the key things they did to improve their search results. In order to do that, though, it means you have to do analysis of your entire data set. You have to find all the inbound links to a page and all the anchor text from all those inbound links. So Solr is set up to pretty easily handle importing records into your index one record at a time. But that doesn't help you when you wind up having to analyze multiple records to get one index record. And that's one of the reasons why Hadoop came out of Nudge, because they were building the system to handle, a billion pages, and to do that analysis on a billion pages. And the last thing is, if you're doing complex analysis, yes, you could do a lot of work in a Solr like import handler, but it's not easy. And if you're doing complex analysis, let's say, you want to do some kind of clustering analysis on your data, that's the kind of thing where Hadoop's perfect. Right? So 3 common reasons why, if your search index is your end goal, is victory, why you would want to use Hadoop in front of it. So how do you actually build one of these workflows using Hadoop? Well, it's really simple. You got your data sources, you got this function of you do something on your data, and then you got the Solr schema at the end that defines what your search index looks like. But of course, it's always a lot more complicated than that. When I teach the class, I talk about the 3 standard steps. Like the first thing you do is you start at the end, and you define victory. So what's the search functionality that I need, and what are often the kind of constraints that I'm willing to accept because it needs to scale, for example. Once you've got that nailed down, then you can look at where does my data come from. And that often, for people working on Hadoop workflows for the first time inside a company, is surprising in that that's often where you spend the most time. It's figuring out how to get access to your data. It's in a database. Okay, you got to do hand-to-hand combat with the DBAs to get the password and the connection settings and everything else that you need to access that data, and what's the schema for it. So you got to figure out where your data is coming from, what's the format of that data. And then finally, once you know, okay, I'm going from here to here, then you can focus on this piece in the middle, which is the workflow, which is the actual Hadoop part of it. And typically the way I teach people how to do that is to think about it as operations on your data that you connect together. And that, for a lot of stuff we do, maps well to this open source project Cascading, where that's how you define your Hadoop jobs, is as operations on data that you connect together in various interesting ways. All right, summary. So, text analytics, right? We're turning petabytes into pie charts, and one of the problems that I see with big data analytics is this issue of validating and understanding the results of processing all that data. A solution that I found useful is the ability to poke at the raw data via search, query type search, and Solr works well as this kind of scalable solution to the problem. All right. Any questions? Somebody's got to have a question here. All the stuff I covered. Anyone? Yeah, the question. Brian. Yeah, it's called Cascading.Solr, and it's in GitHub under the Pixel Labs repo. Anyone else? Any questions about this stuff? No? Okay. So for more information, we do consulting and we do training, and there are some of the rest of the website, my email address, on both the consulting and the training aspects. Oh, there is a question back there.
Somehow to get the use of Solr inside HBase?
Solr. So the question is, can you use Solr inside of HBase?
No, there are plans.
There are plans. There are plans for, like, I think people have Lucandra, which is like Lucene inside of Cassandra. There are various techniques here where if you can get your database into one of these types of NoSQL solutions, it then becomes searchable. That works. The focus here is really more on Solr with the analytics part, like actually doing, workflow processing, which, yes, you could do using Hive or Pig, etc. So there's, one of the great things about Hadoop that I love is there's like 8 solutions to every single problem, and more every day. So I have not explored like the HBase Solr, the Lucene, Cassandra type solutions. I haven't had a strong need to do that yet. But I think if I did wind up having to have indexes that needed to be on multiple servers, I would look at those. I would consider Kata, which is a distributed, Lucene index solution. Elasticsearch. So, we talked about Solr here, but obviously if you're making HTTP requests to the Solr master, you could just as easily be making requests to an Elasticsearch setup. Right, so the endpoint in that case doesn't really matter so much. Any other questions? Yes? So the question is, I'm generating 50 shards, why am I not using something like Kata for that? Well, actually, Kata would be perfect for that, because Kata, you do have to, you can and want to shard your index if the size of the index on any one server is too great. Right, there's sort of two issues with search scaling. One is, how many, I could have the same index running on a bunch of servers that handle load, but there's a second issue, which is if my index gets too big for any one server, then how do I split it? How do I shard it? And Kata supports sharding as well as sort of distribution of the same index. So that would work fine with Kata. And one of the things we do, though, with I mentioned the C1 extra large EC2 instances. So typically we generate 8 shards in that case because they have 8 cores. And I set up my Solr schema so that every request that comes in actually gets distributed to all 8 cores. So the one user's query is getting all of the horsepower in that one server, because I don't care about handling 100 servers accessing this thing. I care about the response time for one user, for the person sort of using it to understand the results. So there are techniques for setting up your Solr instance where you can get pretty good performance off of one box. Any other questions? No? Oh, another question up in front. So comparing Solr and Elasticsearch is probably beyond the scope of this talk. Okay. Both are interesting. I've got a lot more experience with Solr than Elasticsearch because we kind of manipulate Solr in interesting ways for our own purposes, and it's easier for us to do that. But I think I know a lot of people who use Elasticsearch and are very happy with it. All right. Great. Well, thank you very much.